So here's the first problem we want to apply the cosine rule to. Now, before we apply the cosine rule to this problem, let us look and see if the sine rule is applicable. It could be used to solve this problem. Could we use the sine rule to solve this problem? The value of side PQ? Definitely not. The very nature of the sine rule, for the sine rule to work, you would need to have an angle and also the length of the side opposite to that angle. And that's not the situation with this, because we know the angle 37, but we know the opposite side, and we don't know any other angle. So sine rule would not help us here. So we certainly have to use the cosine rule. Now, what does the cosine rule says? We take any side. Any side. But because we want to find the side, the length of PQ, we're going to take side PQ. Alright, so let me just call PQ X. Let me just call it X. We'll call this length, length of this side X. So applying the cosine rule, we say X squared which is what representing PQ, X squared is equal to the sum of the other two sides squared. So it begins the same way Pythagoras theorem begins. So one side square equal the sum of the other two sides square. But we don't stop there. So minus 2 times these very same sides, so 2 times 11 times 8 cos the angle formed by 11 and 8. Or you say cos the angle opposite to the x, which is 37. So x squared, and I pause here, and by the way, when you reach here, it's just one step. Use your calculator and work it out. Let me just use my calculator and calculate that. So I'm punching 11 squared plus 8 squared minus 2 times 11 times 8 cos 37, and I get 44.44. So x squared is equal to 44.44. What is x? X would be now the square root of 44.44. And let me see, the square root of 44.44, that's 6.7. So the length of so x equals 6.7. So therefore PQ is equal to 6.7 units. We don't know if we don't know if it's meters or centimeters or kilometers or whatever, because the question did not give us any units. So PQ is 6.7 to 1 decimal point.